we will be recording our session. And then what we'll do at the conclusion of our training, we'll house this recording out on the YouTube channel. So you'll be able to go out on the YouTube channel, our training channel, and see that.
Okay.
Okay. So this time I'm going to go ahead and share my screen and we'll get our PowerPoint pulled up.
Pass it on you. Pass it on you.
Okay, team, can everyone see the front screen, or it should say session 1 furnace overview TME. Can everyone see that screen okay?
Yep, looks good.
All righty. Well, again, I'd like to welcome everybody to our training this morning. And again, thank you for the opportunity to train with you today. Some of the key topics we're going to be talking about specifically are going to be control board layout. We're going to go over literally every input and every output on the board. We're going to talk about field selection of heating off delay timings. We're going to get into low voltage terminal wiring, airflow adjustments, and then testing flame current towards the end of the session. So if everyone can kind of take a look, the board that we're looking at, this is a typical TM8/9E control board. And so this is going to be single stage heating and up to 2-stage cooling capable board. And so this has been a very reliable board for us. It's been a good board for us. So if you take a look at the board as you were to orient it in front of you, if you had a board in front of you, this is what the board would look like. The other thing I want to point out, with it is the fact that the board itself, we don't have any wires on the board. And so, so this is just strictly to look at the layout of the board without the benefit of the wires hooked up to it. So starting on the left-hand side of the board, let's go ahead and talk about our low voltage terminals to start with.
Hey, Joel, you're getting a lot of feedback. So if everyone could probably mute their mics.
Okay, all right. Thanks for that input, Tony. If everyone would go ahead and mute their mics, and then if we have a question, just go ahead and unmute your mic.
Trent, you guys should be able to do that on the menu bar there on the Microsoft Teams.
Muted, it should be muted.
I had us muted. I'll remute us.
Okay.
Okay. Has that improved it?
Yes. Good to go.
Okay, excellent. All right, well, thank you. All right, so here we go, team. So looking at the left-hand side of the board, we're going to start with our low voltage terminal strip. And so Y1 will be our first stage cooling call. Y1 is first stage cooling call. And again, this board is a single stage heating, but up to 2-stage cooling capable. Y/Y2 will be our second stage cooling call. W will be our heating call. Now remember, team, on a single stage board like this, you're just going to have the single W terminal. On a 2-stage board, you'd have a W1 and a W2, but because this is single stage heating, we're just going to have a single W terminal for our heating input from the thermostat. R will be our 24-volt hot. That's pretty standard in the industry as far as low voltage wiring. G will be our fan on command call. So basically whenever the thermostat's going to call for fan operation, we'll energize G terminal and it'll bring the fan on. Now it should be noted on the ignition control itself, on the board itself, whenever we get a W call, it'll go through its normal heating sequence of operation, and then it'll bring the fan on at a board level function. So remember, team, on a heating call, the thermostat is going to generate a W signal, not necessarily a G signal. So just wanted to make sure everybody remembers that. So on a heating call, the board will generate its own fan signal, but if you get a G signal from the thermostat, that's a separate input onto the fan. And then finally, 24-volt common will be found as a C terminal. And again, that's pretty straightforward in the industry as far as nomenclature on the 24-volt hookup. Any questions or comments so far? So just as a point of doing our virtual training, if you do have a question, just unmute your mic, please, and ask your question, and then I'll address it, and then you can mute your mic back up.
I think we're good.
Everybody good? Okay, well, fantastic. Okay, as we kind of move around the board again, as we look at the board just straight on, right above our 24-volt terminals, there's going to be a jumper selection, and it's called fan speed. Now, this is a pretty cool feature about our Champion TME board, is the fact it gives you some options for continuous fan. Now, this is how this works. So basically, instead of like some of our competitors where if you get a fan-only call, if the homeowner goes over to the thermostat sub-base assembly and they select fan auto to on, the fan's just going to run either at 50% or typically 100% airflow. This jumper right here gives us some options though. So if you want the fan to run something at other than 50% or 100% airflow, this jumper right here allows you to select at what speed the fan is going to run on a continuous on fan call. So the selections are going to be like G, which is going to be a very, very low speed if it's just a G only call. You can also run the fan at high cool speed or low cool speed, or you can also run it at the heating speed. So that's kind of neat. It gives you actually 4 selections of how fast you would like the fan to run in the event you went to on the thermostat sub-base assembly, the fan from auto to on. So it gives you some nice options for continuous filtration, especially if the homeowner is enjoying or if you've installed some IAQ devices, for instance, like really nice air filtration system. Oftentimes they like to keep the fan running all the time to keep that air moving through the filter. So that gives you some really nice options other than just off or on. We actually give you 4 speed selections for continuous fan. Right above that, we're going to have another jumper selection, and this is our blower off delay function. And so what this does for you, this allows you to field select when the fan's going to continue to run after the call for heat is terminated. So it normally comes from the factory at 120 seconds. However, it is field selectable from 60 to 180 seconds. And so basically, once the call for heat goes away, how long does the fan continue to run before it shuts off after the call for heat goes away? That's what we call our heating blower off delay function. And that is field selectable from 60 to 180 seconds. Any questions or comments on those 2 jumper selections before we continue? Is everyone good? The guys at the table, give me a thumbs up. All right. That works pretty good because I can see you cats pretty easy down in the corner of the screen right there. Okay, we have a last error button right above our jumper selection our jumper selections. This last error button, team, what this does, it allows you to go in and retrieve errors off the board. Now, it should be noted, if you depress the last error button, you can start cycling through the last 5 errors on the board, so it will actually remember the last 5 errors on the board. In addition, if you take that button and you hold it down for about 10 seconds, it'll clear the memory. So oftentimes service technicians, what they like to do is they'll go ahead and clear that memory so that if there are any fresh faults on the board, they can actually come in and read those at a later date. So that last error button, it allows you to get in and look at all the errors on the board, the last 5 errors, it remembers them. But in addition, it allows you to clear that memory if you hold that button down for about 10 to 15 seconds. As we move around the board, you'll notice that there's a flashing LED. And this flashing LED that we have on the board, that's actually a fault or a status LED. Now that status LED will either flash one of 3 colors. It'll flash red, green, or yellow based on the flash code. Now it should be noted that LED is going to give you various flash codes or various fault codes depending on the fault code. And so if you take a look at the service information that comes with the furnace in the install guide, In addition, I believe we also have it printed on the inside of our service panel on the furnace itself. So if you remove the service panels, you can turn them around and you'll see a schematic, and you'll also see a little legend that'll tell you what those flash codes mean. But the flash codes really, really help the technician, figure out what's going on with the furnace. And to give an example, if you have like a 3 flash code, that tells you there's something going on with the pressure switch. So you may have a venting issue. If you have like a 4 flash code, that means it overheated, and so on. So by looking at the flash codes and counting the flash codes, it really helps narrow down what's going on with the furnace. If you have some safeties that have tripped, or if you have some airflow issues or what have you, and the heat exchanger is overheating, and so on. So, but those flash codes are very, very handy. But that's where you find it, is on that little tricolor LED. And again, team, it'll flash either red, green, or yellow. Any questions or comments on that flash code, or more specifically where I would look or observe a flash code on the control board? Any questions or comments? Everybody good? Okay. Well, fantastic. So moving around the board, remember, team, this is an ECM type of motor, a high efficiency motor. So the way this motor works is we're going to have power to it all the time. So anytime there's power to the furnace, there's going to be 115 volt to the motor itself. But the motor's just sitting there waiting for 24 volt commands. And so this is where we're going to start showing you how we're going to control that motor with 24 volt commands. So where it says 24 AC or 24 volt AC motor, on those terminals up there, you're going to find a park terminal for any unused motor taps that you're not using. That's where you'll put it, on the park terminal. Then you're going to notice there's another terminal that says G. Now that G terminal is going to go down, and you're going to select a fan speed appropriate to like a continuous airflow. So in other words, if you just want to have continuous airflow going, a nice low airflow going across that air filter all the time, typically you're going to find that G is going to be selected on low speed on the fan. So G is typically going to be low speed on the fan. In addition, you'll find right next to the G terminal, you're going to find a 24 volt C common. And so what that is, that's a 24 volt input to the motor itself, but it's the common. It's 24 volt common. So those terminals right there will be going down to the motor on the 24 volt terminals. And again, G will be typically selected on your lowest speed, and then 24V common will be to the common 24 volt common terminal on the motor itself. As we move around the board, we see we also have some motor speed taps. We have low cooling speed, high cooling speed, and then our heating speed. So these speed taps, we'll have to select the proper speed taps on there based on our cooling airflow needs and our heating airflow needs based on our furnace, filtration and ductwork and so on. So when we commission the unit, or when we install the unit, we have to make sure and select the proper speeds to give us the proper airflow. Now at this time, I'd also like everybody to really take a close look where it says low cool and high cool. So even though this TME, this basic single stage heating control board is just a single stage heating unit, we have the capability of having a low cool and high cool for a 2-stage piece of equipment. As a matter of fact, one of the things I really, really like about our Johnson Controls and Champion TME board here, furnace, is the fact, even though it's single stage heating, this thing will literally hook up with anything in our inventory except our 20 and 21 SEER momentum unit. So if you have a 17 SEER 2-stage unit, this thing is perfectly compatible with that. If you want to do like a dual fuel 16 SEER with our 5-stage TH16, this furnace is perfectly compatible with that unit. So it's a very, very versatile unit. And we find a lot of our Win locations, actually, this is kind of their base model to where they sell a lot of these TME furnaces. They're very, very good furnace. They've been a very reliable furnace for us, and they work well. Any questions or comments so far on the motor speed taps and the basic idea that this board, even though it's a single stage heating board, we can literally hook it up to any of our 2-stage equipment as well, and even our 5-stage TH16 5-stage heat pump as well on a dual fuel. Any questions or comments on that? Everybody good? Okay. Well, team, as we move around the bottom of the board, or as we come down the side of the board, I should say, you'll notice there's going to be an EAC terminal. This EAC terminal is 120 volt output for an electronic air cleaner. And so anytime the fan is running, this EAC terminal will be energized 120 volt, and you can use that to power an electronic air cleaner. As we move down the board, we see we have a 120 volt input, L1. This is our 120 volt input to the board that's going to run our 120 volt components. For instance, our transformer primary will be hooked into this 120 volt circuit. In addition, as we mentioned earlier, the ECM type of motor technology we're using, that high efficiency electronically commutated motor, that's what ECM motor means. It's a high efficiency motor. It has power to it all the time, but it's not doing anything until we command it with a 24 volt speed command. But the power that comes into the board that powers all these 120 volt components up is going to come in on that L1 terminal, and that's where the power comes into the board from our power source. Right below L1, we have XFMR. Now the XFMR, what that is, that's our primary lead to our transformer. So that's our primary high voltage lead to our transformer. Right below that, it says line. Now this is interesting. The line is actually the power going to the ECM motor all the time. So L1 is where the power comes in, but where it says line, that's what's powering the ECM motor up all the time whenever we have power to the furnace. Right below that, we have a HUME terminal. That's for a humidifier output, and that's 120 volt output for a humidifier. Now, it should be noted that's an isolated relay output, 120 volt output. And the neat thing about that is anytime you have a heating call, you can take that 120 volt output and you can utilize that for the purposes of powering up a humidifier. Okay, right down, whoops, hold on. We're having a little PowerPoint glitch here. Give me just a second. There we go. Right below the HUME terminal, we have neutral terminals. Those neutral terminals, you'll find that this is where all of our white wires, or the neutral wires coming in from our 120 volt components, will be tied in. We'll have a neutral wire, for instance, going up to the ECM motor. We'll also have a neutral wire going up to the transformer. And so that's where those will tie in. Team, I've just noticed on my presentation that my little window that allows me to see everybody in the room has gone away. So what we're going to do from this point on, if you do have a question, please unmute your mic for me and then ask that question, and then we'll go ahead and get back to it. Because like I said, I've lost the little window where I can actually see everyone in the training room with a thumbs up.
Okay.
All right, thank you. Okay, as we move around towards the bottom of the board, King, we see that we have an output harness to our hot surface igniter and our inducer fan motor. And so we'll harness in right here, and it's just a little 4-pin harness. And that's going to be 120 volt output to the hot surface igniter and our inducer fan motor. As we move around the bottom of the board, team, we're going to see we have a flame current pad. Now, this is really a neat feature on our Champion furnace, because what this does, it allows the technician to take his voltmeter and read flame current directly off the board. Now, you can still, if the technician still has a flame current meter, he can still use that if he wants to by unplugging the flame sensor and hooking his meter up appropriately. But this flame current pad, we feature this on all of our Johnson Controls Champion furnaces. It's a really slick feature. And so now a technician doesn't have to have a special meter. All they do is they take their voltmeter and they go to DC volts, and then they read the voltage on those two little spots right there, those two little contact points with a DC voltmeter. and 1 volt DC equals 1 microamp flame current. So now, you know, the meter that they have on their truck, which is, you know, they're going to have a volt ohm meter more than likely. Any technician out there that's doing this is going to have a voltmeter. So now instead of having a special meter, you can just go in with your voltmeter on a DC voltage scale and read the flame current right off the board, which I think is a really slick feature on our Champion furnace. We move around the board, we see we have a 3 amp fuse for 24 volt onboard protection. And so this is just a cartridge automotive type fuse. And those are typically going to be 3 to 5 amp fuses on the board. Right next to the fuse, we have a 12-pin harness. Now this 12-pin harness will of course be harnessed in from the factory, but if you remove that harness, you'll see that there's actually 12 pins there. And this 12-pin harness is going to give us our inputs and outputs to things like our gas valve. Our safety circuits will all be harnessed in on this 12-pin harness. Okay, so that's the basic layout of the board as far as inputs and outputs. Is there any questions or comments on the outputs or the layout of this board before we continue with some other things to overview on our furnace? Any questions or comments?
No, they're good.
We good? Okay. Well, fantastic. Well, team, at this time, we're going to talk a little bit about measuring flame current, and it's something that we're going to do. I'm going to make it a point that we'll measure flame current, or we'll go over measuring flame current on each one of our furnace overviews, because I think this is a really important thing. This is something that I think technicians, you know, they need to be able to do this, and I'm going to recommend that every time you make a furnace service call is to go ahead and check that flame current, because, you know, the flame current sensor, or the flame sensor, it can get dirty, and we recommend that if they're going to clean that flame sensor, to use something like Scotch-Brite to clean it. Don't use sandpaper, because if you use sandpaper, it can deposit little pieces of sand on that flame sensor, and then of course when it fires up the next time, that sand, the little particles of sand on that will actually melt and make a little glaze, or almost like a little glass coating on there. So we don't recommend to use sandpaper to clean our flame sensors. But what does work well is Scotch-Brite. You know, just go down to your local hardware store or grocery store and get some Scotch-Brite. That works well. Another thing I used to use quite a bit when I was in the field, I had some stainless steel wool, and that worked very well. And I like the stainless steel wool because it doesn't rust and whatnot in your toolbox in the back of your truck. But stainless steel wool works very well too to clean that flame sensor. And so this is something I believe every technician needs to have the skills and the tools to do. So basically, to measure flame current, we found out a little bit ago on that flame current pad, all we need is a DC voltmeter to read flame current. But before we get into reading flame current and some of those specifics, let's go ahead and talk a little bit about the science of flame rectification, and then we'll talk about measuring flame current. So flame rectification is basically a science that we're going to provide AC voltage to our flame sensor all the time. Now this is interesting because the flame sensor is actually powered up anytime the furnace is powered up. So if you've got power to the furnace, you're going to have line voltage on the flame sensor. And a lot of technicians don't realize that there's actually line voltage on the flame sensor. However, that circuitry is an extremely high resistance circuit. So if you were to touch the flame sensor, or if the flame sensor was shorted to ground, you know, it's not going to burn anything up. It won't even shock you, because we're talking about hundreds of millions of ohms of resistance. So even though there's voltage there, there's no current. And so we're talking into the microcurrent ranges here. So, but the science behind it is this. So flame rectification, anytime the furnace is powered up, we have AC voltage going to the flame sensor, and it's line voltage driven. So if there's no flame current, nothing happens. You know, if there's no flame present, nothing happens. You've just got AC voltage going to this flame sensor that's not touching anything. It's just got voltage on it. and there will not be any current flow, through the board or through the ground system if there's no flame present. Now watch this. When we put a flame to that flame sensor, what happens is the AC voltage goes through the flame sensor. It actually goes through the flame itself and then to chassis ground, because the burner's grounded, to the chassis ground. And this is really, really important. If a flame is present, what happens is that AC voltage goes through the flame, and the flame actually rectifies or cuts that voltage signal in half. And so we see that we have AC voltage going to the flame itself, or the flame sensor. It goes through the flame, and then the flame actually cuts that voltage in half, and we see a pulsating DC voltage going back along the ground plane back to the control board. So this is why it's so very, very important. If a technician should ask why, or if you wonder why is a grounding so important on a furnace? Well, this is why. Because if you don't have a good, clean, solid ground, the board cannot sense the flame. And so the actual ground itself, the chassis ground itself, is the other side of that flame sensing circuit, as you can kind of see in the graphic here. So we have AC voltage going to the flame, going through the flame, and then along the chassis ground, we have pulsating DC coming back to the board, and the board senses that. And if it sees pulsating DC or DC voltage on the ground plane, then it knows there's a flame present, and gas flow continues. It continues to keep the gas valve open. So that's the basic science behind flame rectification. Now, it should be noted, one of the things that's very, very important to remember is, again, you have to have a really good, clean ground, and the polarity on the furnace has to be proper. So in other words, if you're hot and your neutral are backwards on the furnace, on your power source coming in, now if your black and white wire are reversed on the power coming into the furnace, it will not be able to sense the flame. So those are the two big things that we find a lot of times, especially in an older home. We don't have a good ground in that home, and we don't have good flame sensing, or if the technician or the installer gets the black and white wire mixed up, what'll happen, it won't burn anything up or anything like that, but the point is it won't sense the flame. So it's very, very important. Polarity has to be correct, and you have to have a good, solid ground in order for this flame sensing circuit to work properly. Any questions or comments on this basic science of flame rectification and how it works? And we'll get into measuring flame current here in a second or two. Any questions or comments?
We got a question.
Sure, come on.
Does the process get affected at all if the house or breaker box itself isn't properly grounded?
That's an excellent question. Yes, it can. And so this is why it's really, really important, and to kind of expand on that good question, basically the furnace has to have a good solid ground at where it's actually located, but that ground has to be a really good solid ground all the way back to the power panel and then down to earth ground. And so yes, so it's very, very important that there's a good solid grounding system in the house in order for the flame sensing to work properly. Good question.
Yeah.
Yeah. Any other good questions or comments?
No, you answered it. Thanks, Joel.
Okay, good. Fantastic. Well, team, let's talk a little bit about actually measuring flame current as we kind of start winding up towards the end of our training session. Now, what we did, we pledged to keep this, to about 45 minutes or less, and then we can certainly open the floor up for questions as well. But we're going to try to do all of our training sessions with you guys, between about 45 minutes and an hour, as promised. So we'll try to certainly stay on that schedule this morning. So measuring flame current, team, as we mentioned, so here's our control board. And the first thing we're going to do to measure flame current, we're going to call for heat, and we're going to let the furnace establish normal flame. Now, and this could take, it's going to take about a minute or so for it to go through its normal sequence of operation. And I like to let the furnace warm up a little bit and actually start blowing air into the space, just like it's a normal heating call. Then what we're going to do, we're going to take our voltmeter and we're going to set it to DC volts, and we're going to go down to our flame current pad, and we're going to read the the voltage, the DC voltage between those two little points. And remember, team, 1 volt DC on your meter is equal to 1 microamp DC flame current. And then the flame current, it should be above 1.5 microamps. Now, if it's below 1.5, the furnace will still continue to run. However, we'll generate an amber flash code indicating that we have low flame current. Now, please write this down or make a mental note of this. Typical flame current on our furnaces, if you have a good solid ground and the flame sensor's clean and all those things are met, and the furnace is fired properly, and you know the manifold pressure is correct on the gas valve and all that, typical flame current on our furnaces runs typically from about 3 to 4. You know, and so 3.5, 3.2, those are all really good numbers. But it should be noted that if the flame current falls below 1.5, you get a flame current. You get an amber flash code indicating low flame current. Now, the furnace doesn't actually lock out until, watch this, 0.1 microamp flame current. So we're talking very, very low. So we have a real wide window of operation there, but we'll start generating an amber flash code at 1.5, but the furnace won't actually stop working until you have a 0.1 or less. It'll actually lock out and shut down on low flame current. But typical flame current is about 3 to 4. And so, again, very, very easy to check. Just use your DC voltmeter and those parameters that we mentioned, 3 to 4 for typical flame current. And if you got a good clean flame sensor and a good ground, you should have those flame current readings within that range. So any other questions or comments on reading flame current or flame rectification as we kind of start rounding out and concluding our training session for today? Any questions or comments on that?
Go ahead.
That flame sense number is way off base based off of my experience. I've put in hundreds of these units, and average I'd say is about 2.2.
Really? That's
Absolutely. Absolutely.
That's interesting. You should say that, because if you take a look at our install information, they'll tell you the typical flame current, I think, is like 3.2, but my field observation has been somewhere between 3 and 4 if flame sensor is good flame and you got a good ground. So you're running about 2.5 out there typically. Is that correct?
Yeah, that's even high, honestly.
Are they grounded?
Yeah.
Well, one of the things to kind of keep in the back of your mind is, especially if they're older houses, double check that grounding at the service panel, because if you don't have a good solid ground all the way to that earth ground or that earth, that grounding rod, that will affect it.
Yeah, we're dealing with a lot of older homes around this area, and these are almost all replacements that we're dealing with here.
Okay. Here's a little electrician's trick just for fun. If you suspect that you've got a poor grounding in the house, what you can do is go out to the service panel and go 3 or 4 feet away and just drive a piece of conduit, or put a rod into the ground and pour some water around it, and then take your voltmeter on a very, very low scale. We're talking like a 10-volt scale, and stretch your voltmeter on AC volts between the existing earth ground and then that temporary ground that you put in the ground, and see if you have any voltage there. If you've got any voltage between those points, it'll tell you that you've got your ground could be improved. So that's kind of an old electrician's trick.
Interesting.
Yep. I spent almost 20 years in the field, and I found that most of the time, older homes, they could stand a new ground rod or whatever put down, because that will help improve that. Good. Excellent questions. Any other questions or comments?
No, I think that's it. You guys got any questions? No, we're good.
Okay. Well, at this time, team, that concludes our PowerPoint presentation. But let me go ahead and get back to our to our live session. Is there anything on the furnace that anyone would like to look at on in our virtual session? You'd like to take the camera and look at anything or talk about anything?
Did you get your video back, Joel?
I did. I've got the video back right now,
Okay, hang on.
and I've actually gone to full screen with you guys. So if there's anything on the actual furnace to talk about.
I don't know how they do it. You can take it off the table if you need
I think this will work.
We put the furnace on too.
to. No, somebody scratched the table yesterday.
That's sideways, isn't it?
It is sideways.
Hurry up, take it off.
You want me to turn the furnace sideways? How's that?
That looks a lot better. So if anyone has any questions or they would like to come and point or ask about something with the furnace, we can certainly help address that. But I mean, I can kind of see it sideways, or it doesn't really matter. It all looks about the same.
Come on over, guys. Okay, I got the furnace up and they can show questions if you got anything on here that you guys want to go over.
I don't really have any questions.
Yeah, I was about to say,
That part of it, I'm pretty confident in. Most of this is what was actually really good information.
I have a couple of comments.
Okay, go ahead with a comment.
I've ran into twice now, there's
drain line.
one of the screws behind the inducer motor is not
Okay.
properly screwed in, allowing a leak. I was wondering if there was any way to, repair that without ripping out the whole inducer motor.
Have you now? Is a part of the induced draft blower housing itself?
Yeah, and it's just one of the screws at the very bottom right behind the inducer motor is not screwed in, so we're getting 6-month-old furnaces that are leaking like crazy. And you gotta take the whole inducer motor off to actually secure that screw in.
Yeah, and that's the only way I know to do it. But would you do me a favor, please? If you could generate some serial numbers, what we could do, we'll get that to our technical support folks, and we'll get that to our quality control people, because that's something that we need to know about.
Alright, I don't remember which ones exactly they were going back, but I'll do that in the future. But it's happened enough times for me to tell you that it has happened.
Absolutely, we definitely want to know stuff like that, because those are the types of field reports we're very, very anxious to hear. So thank you for that information.
Got any other improvements you think?
One observation from an installation perspective.
Okay.
Right. All right, there we are. Right here, where our drain comes through.
Okay.
A lot of times, the chassis doesn't quite line up, the exterior of it with the plate inside of here.
Okay.
And we have to drill this hole out to get our fitting through.
Okay. So when you're in like a horizontal right application.
Well, I mean, either, even if you're just draining to the right, or to the left necessarily, it's a rather frequent occurrence. Like I said, I've been putting in, York family furnaces for a couple of years now, and it's a pretty frequent occurrence that these plates just don't quite line up.
Okay. Okay.
And so, then installers in the field are having to make modifications to the cabinet
And so basically, just from a practical, so I can wrap my noodle around it, you need to enlarge that hole a little bit with like a unibit or something so that will pass through.
Yes, exactly, exactly.
Okay. I'll definitely pass that one on as well. Good, excellent.
Yep.
Joel, I had another thing that, Dave, the, owner of the company here, he had suggested a while back, what it was on the ACs, on the TC3Bs and the TC4Bs.
Okay.
The hub for the line sets. He's asking because a lot of people are doing more of the, press fittings on line sets. Now the hub isn't really necessary anymore for grazing, and they're wanting to see if it's a possibility, or if there's any plan in the future to try and eliminate the hub.
You know, that's an interesting thing. I was at our last technical conference. We actually had quite a dialogue, you know, from our, you know, from all of our locations around the country at our national technical conference, you know, across all of our brands, and that was actually something that our engineers were looking at was some of those press type fittings, you know, those no sweat type fittings.
Yeah, Zoom Lock's the main one, but yeah.
The last I heard, you know, they're still in the process of vetting and approving, you know, the particular brands that they'd like everybody to use. To my knowledge, they haven't made a service letter yet as to which one we like, you know, whether it's Nyco Press or whether it's whatever. And so, but what brands are you guys using to put those together for the, you know, the no sweat fit?
I do Zoom Lock at the store, but these guys haven't bought any from me, so I'm assuming.
Yeah, we don't use the Zoom Lock. Oh, gosh. Yeah, Josh, will you grab a pair of those fittings from the back?
Yep.
Thank you. I can't recall so the Zoom Lock is the actual press fitting. We use we use push-ins that we buy from Bill, and
That's the Rector Seal version. I don't know the actual brand. Brand that Rector Seal is on it.
And then also ones that you crank together. You put it in, and then you take a pair of wrenches and crank them on.
Okay. Well, let me ask you guys this: if we went to a service valve that didn't have that swedge or that hub on the end, and you got into a situation of grazing, would that be a problem? Like putting a coupling there? I mean, would that be a problem for you if we didn't have that bell on the end?
So if you didn't switch the bell end onto the service valve, but leave the same amount of material, that would be excellent. If or alternatively, we could leave you know the bell end on and put more material there, because one of the problems that we face is cutting off that swaged end. You get left with very little material on the suction line. I mean, you can look at it, it's proportionately a bit shorter than what you get on the liquid side, and it's really hard to get our fittings to get all the way in there, seated properly.
Okay. Well, what I will do is that's a subject that I'll bring up. We have our national technical conference coming up next month, and that'll be a subject that I'll bring to the table, definitely.
I appreciate that. Thank you.
That would be
You bet.
really cool. Yeah.
Anything else, guys?
Fantastic. Do we have any other questions or comments this morning?
It seems like we ran out of those.
Okay. Guys, I'll tell you what, I sure appreciate training with you this morning, and I look forward to doing this again in the near future. And if there's no further questions or comments, I'm going to go ahead and stop the recording, and then we'll go ahead and conclude our meeting if we don't have any further questions.
That's it. I appreciate it. Thanks, Joel, and everybody else, and Jill.